Hey there, this is Vedat from Programmership. In this chapter, we're gonna talk about protocol. Protocol defines blueprints of methods or properties that can be applied by class or structures. It works like an interface in the other languages. Protocol is a powerful feature that is also used in Swift standard libraries. When we conform to a protocol from a class or structure, we need to apply the implementation of protocols into our class or structure. Let me show you how to use it. I'm going to define an empty protocol. For that, we will use protocol keyword. Protocol, and then we will define our name. Let's say test protocol, and that will be empty. So let's create a class. Test class. And our test class will conform to test protocol. Let's say test protocol and leave it empty. For the struct, let's say test struct. This will also conform to our test protocol. So that is the simple usage of protocol with class and structure. A class or structure also can conform to multiple protocols. Let's add another protocol. Here, let's say protocol test protocol 2. And with the comma, we can add the test protocol 2 as well. And let's do the same for the struct, just like that. Now, let's add a property into our protocols. To define a property into a protocol, we also need to indicate whether our property is read-only or read-write. We can specify this by get and set keywords. Let me show you. Let's say var name, that will be in string type. And between the curly brackets, I will define it as read-write. Let's say get and set. Get for read, set for write property. And for the test protocol 2, let's add surname. Surname, that will also be string. And here inside, let's make it read-only. To do that, I will just say get, no set. Here we just define a name property with a read-write feature in our test protocol. Also, inside the test protocol 2, we define a surname property as read-only. So as you can see, when we add a property inside a protocol, compiler gives an error. So it seems we have to apply the properties inside the protocols. Let's say fix, and the properties inside the test protocol and test protocol 2 was automatically implemented into our test class. So let's do the same for the test struct. Hit fix. And inside the test class, we can change the surname directly and give some string. Let's say Oslo. Also, let's create an initializer for our test class. Let's say init. And inside, we can define a default value for our name property. Let's save that. And let me change the surname in the test struct as Oslo2. But of course, we need to make it equal. Please note that if we create an instance of the class or structure, we can change the surname property value through that class or structure, even if it is defined as read-only. I'm gonna show you what I mean. First, let's create an instance of our test class. Let's say var my instance is equal to our test class. And in the next line, let's say my instance dot surname is equal to my surname. And let's try to print the my instance dot surname. And don't forget the surname property is read-only. Let's hit run. We can see the surname property was changed into my surname, even it is defined as read-only. If I define the my instance variable type as test protocol 2 and try to run the code, it shouldn't change the property. So let's try to give a type for my instance. Let's say test protocol 2. And here we can see the compiler gives an error. It says the surname is a get-only property. I know it sounds weird, but it works like that. It is also alright to specify the type of my instance as test protocol 2 since our test class conforms to that protocol. So let's define a method inside the protocols. I'm gonna define getName and getSurname method. Here inside the test protocol, let's say func getName, and it will return back a string. We define method without body in the protocols. And inside the test protocol 2, let's try to create a method called getSurname. This will also return back a string value. here inside the test class and test struct, Swift compiler gives an error. And when I hit fix, it will implement the getName and getSurname methods automatically. And let's do the same thing for our test struct. Hit fix, just like that. So we will define our method's body inside the class and structure. Let's say return self.name. And for the getSurname, return self.surname. So we can move these methods at the bottom of our initializer. And let's do the same thing for our getName and getSurname in the test struct. Return self.name and return self.surname. We can also move these methods at the bottom. Well, let's try to access these methods. Here, I just want to create an instance for our test struct. And here, because we didn't specify any default value for the name property, the struct initializer needs a default value for name property. Let's say Vedat. And in the next line, I want to print the myInstance.getName. Also print the myInstance.getSurname and hit run. It works. Alright, here I want to show you something. As I just said, if we define a property or method into a protocol, we need to apply them to our class or structure. But there's a way to get rid of applying these methods or properties. We can create an extension of a protocol and create those methods and properties inside the extension. Then we would not need to apply it in our class or structure. Let me show you. First, let's delete all of these methods inside a struct and also inside the test class. Here at the bottom of test protocol, let's define an extension for the test protocol. And inside the extension, let's add a body for our getName method. This will return back the name. I forgot to add string, the return type. So let's do the same thing for our test protocol 2. Extension, test protocol 2, and inside, let's create a body for getSurname method. It will return back string, and inside the getSurname, let's return the surname. And here we can see even we did not add any implementation of getName or getSurname inside the test class or test struct, no error, no problem. Let's try to print again, and it still works. We don't need to apply getName and getSurname methods into our test class or test struct, but of course we can still add these methods into our class or structure if we want. When we define an extension for a protocol, we can add extra functionality for that protocol. This usage is very common among the developers. Finally, I want to make a basic example of protocol usage for better understanding. First, let's delete all of this. Suppose you have an app that has a login page, and let's say there are two kinds of login, one for normal users and the other one for admin login. Each login type may have different logic. So let's make a structure for that login section. First, I want to create a protocol that has login method. It's a protocol, and I'm gonna name it as login protocol. Inside the login protocol, let's add a function for login. And this function needs a username that will be string and a password. This is also string. Now, let's create two structures for each login type and conform those structures to this protocol. Let's say struct user that will conform to our login protocol, and also another struct for admin. So inside these structs, we will implement the login function. Let's say fix, it will add automatically, and for the admin, let's say fix. And inside the login method, I will just add a simple logic. Let's say if username is equal to password, then simply print admin login succeeded. If it is not equal, then let's say please check your admin credential. And let's do the same thing for our admin login method as well. Sorry, that must be user, and this is for admin. And I will create another structure for managing the login section. Let's call it as login manager. Login manager. And inside, let's create two properties for username, that will be string, and for the password. And also, I want to create a method called login. This time, we don't need the username and password, but a user within login protocol type. And inside the login method, let's call the user.login. For the username parameter, let's say self.username. For the password, self.password. Here we define the user type as login protocol, which makes sense because our user and admin structures already knows about login protocol. So now let's create an instance of login manager and try to log in. Let's say var my user is equal to login manager. Inside, let's give a username and a password. Let's say 123. And in the next line, let's say my user dot login. And for the parameter, we will pass the user instance. Let's hit run. And it says, please check your user credential, which is the else statement of our user struct. If I give the password just like the username and hit run again, and it says user login succeeded. So let's do the same thing for admin login. Here I want to define a new instance. Let's say var my admin is equal to login manager. The username will be without the password. Let's give it different than without. Let's say 123. And in the next line, let's say my admin dot login, and I will pass the admin instance. And let me delete the user instance. Hit run. It says, please check your admin credential, which is the else statement of admin struct. So if I change the password as without and hit run again, it works as well. Alright, that's it for this chapter. I hope you have learned something. See you in the next one. Goodbye.